Good evening, everyone. Welcome to CML InfoTech. My name is Muhammad Ali, C. Latif. We wish to talk about Cisco CCNA second day session. In a previous session, we were discussed about the certain area from the switching concept like access switch, distribution, core, and server farm switch, and some certification criteria, certification track. This was the hot topic that we were discussed already. Moving forward, we wish to have the discussion about types of network. LAN and WAN, local area network and wide area network. They were another network before, like MAN. But being to consideration, we wish to discuss about local area network and wide area network. When we talk about local area network, when your systems or any edge devices are communicating near each other, either via wired or wireless, that could be considered as your wired network. Let's say you have few devices. Let's say in an easy way, I have one system. Let's say PC1. I have another computer, PC2. I want to communicate, I want to enable the communication between them from PC1 to PC2. So I have a two choice to make them a network, either via wireless or via wired. If I'm thinking to connect between them via wired, I have to have NIC card, network interface card here and in the system. Network interface card, and I have to pull the cable between them. Let's say copper cable. Copper cable. So this type of network we can consider as local area network, LAN. If I have more than two devices, let's say I have one more device here. I want to make them under the network AC3. Or even I have any other edge devices. Let's say I have access points, or I have camera, or I have any other edge devices which need to be under network. Here I cannot pull the cable straight forward from one device to another and from the another devices to next another device. I cannot connect like this. Here I must need to have a central device that could be repeater or hub or bridge or switch. I can use repeater, or I can use hub, or I can use bridge, or I can use switch. I can use any one of the devices. These are the series of new devices. Let's say after the repeater, hub, after the hub, bridge, after the bridge, switch, and currently we all focusing to connect it to the switch. I must need any one of these central device, and these central devices I should connect from every devices to the central devices. എല്ലാ ഓരോ ഡിവൈസിൽ നിന്നും ഞാൻ ഈ സെൻട്രൽ ഹബ്ബോ ബ്രിഡ്ജോ സ്വിച്ചോ റിപ്പീറ്ററോ ഇതിലേതെങ്കിലും ഒരു സെൻട്രൽ പ്രോഡക്റ്റിലേക്ക് നമ്മൾ കൊണ്ടുപോയിട്ട് ഇങ്ങനെ കണക്ട് ചെയ്യണം. I have to connect from here. This shouldn't be the center. This must be somewhere in the IDF or in the rack. So this type of network we can consider as LAN, local area network. is there any limitation to build a local area network? That's the one question. You can implement the local area network until your cable reachability. Like when we have a copper cable, we generally used to say that must be within the 90 meters. If we expecting to expand it, we have to have some other equipments in between, like for example, repeater or extender and etc. But for now, when you have the network more than 90 meters, we would like to have a fiber connectivity. It will come in the upcoming sessions, fiber connectivity. So the local area network that you can develop and implement, where you have a campus building or forest building or any kind of that type of architecture. ഒരു ഡിവൈസിൽ നിന്ന് നിങ്ങൾക്ക് വലിക്കാൻ പറ്റാവുന്ന അത്രയും ദൂരത്തിലുള്ള ഒരു നെറ്റ്വർക്ക് കണക്ടിവിറ്റി നിങ്ങൾക്ക് ഫൈബർ കേബിൾ വലിച്ച് ബിൽഡ് ചെയ്യാൻ പറ്റുമോ, അതെല്ലാം will be considered under the local area network. Okay, then where you will be considered a wide area network. Example, you have many devices here which you connected to a central device. Maybe you have here in let's say here in Doha, you have one network. Then you have another network, for example, somewhere in Lusail. Let's say you have set of network in one building within the far place, for example, in Lusail, which is also connected to a central product. Now you need to connect between them. So we generally recommended to have a connection from the ISP. Let's say this area I wish to consider as ISP. Maybe we have a Vodafone, or maybe we have Ooredoo. So the Ooredoo or Vodafone ISP will give you the connection to your office. Then your office must have a device to convert between them. That is, we call it as a router. The router. So here also you have a router connected to your network. So when you have a router which will be accepting to connect to the far end network, this is called WAN, wide area network. So to develop or to implement your LAN technology as well as WAN technology, either wired or wireless, along with the equipment that you need, you also need the technology. Hope you understand. ഒരു ലോക്കൽ ഏരിയ നെറ്റ്വർക്ക് ആവട്ടെ, വൈഡ് ഏരിയ നെറ്റ്വർക്ക് ആവട്ടെ, അത് വയർഡ് ആവട്ടെ, വയർലെസ് ആവട്ടെ, എങ്ങനെ കണക്ട് ചെയ്യണമെങ്കിലും അതിന് നിങ്ങൾക്ക് equipments വേണം. Example, laptop, desktop, whatever the edge devices, switch, router, ഇതെല്ലാം വേണം. Along with that, ഈ ഹാർഡ്വെയർ ഡിവൈസിന്റെ കൂടെ you also need a technology. Or even I could easily referred as a protocols, one of the technologies. Maybe you heard about Ethernet, IEEE 802.3, 802.11, or the latest one we call as TWAN, or I could say MPLS, VPN, MPLS VPN, Star 25, 3G, 4G, FOMA, HSPA, Edge Plus. There are many different technologies are involved in order to develop the network. It could be wired or wireless, either within the LAN or the farthest network, maybe it's called WAN. Okay, so by reaching to this moment, what you guys need to understand in a short way, what is LAN and what is WAN. Local area network, which is the shortest network or the network where you can be implemented within the local places. Wide area network, which you cannot easily pull the cable to connect between them. Therefore, you must need a support from the ISP who can provide you the connection until your destination. That's called the wide area network in a general terminology. Okay, and just wanted to convey one more thing. There are a couple of points which you already knows, and you need to still understand in a better way in a piece of portion. Later, all the piece of portions will be migrated into whole topics. So in order to clearly understand one complete full topic, you need to wait for multiple small pieces. It is, do not confuse in between, that's saying in different way. No, you have to have a patience to understand the complete topic until we reach the final shape. So in between, even you can ask any questions that we can easily answer both at the same time. So here, if you look into this wide area network, and you can see a symbol in the round shape, that's the symbol of router, where you can connect with the multiple different locations. And here are some of the common symbols. So when I design the diagram, we are mentioning certain icons that you need to understand the meaning of those icons. In the initially, I'm gonna give you some design related to the topics. Later, you must need to design by yourself and to make sure that the design are perfect. The intention into this, one of the intention to this course is that you all need to be designed in a proper way in after few classes. So here you can see the firewall, IP phone. So let's say a few of the common icons, which I can give you an idea here. Let's say if I'm writing, this means bridge. And this is hub. If I'm writing either 2-line, or if I'm writing like this, or if I'm writing okay. So here we can see that this is called switch. We have a upcoming topic to explain about each product and the difference and the reason for introduced the new devices. In a short way, you just need to understand in an easy way that initially introduced a repeater, but after identify the limitation of the repeater, they came up with a hub. After the hub, with the limitation of the hub, they bought a bridge. The bridge is the solution of the hub. And from the bridge, they found certain limitations. Then from the bridge, they came up with the solution called the switch. And even in this switch, we also referred as a layer 2 switch. Then we have another devices called, either you can write like this. This is called layer 3 switch, or We also referred as MLS, multi-layer switch. I'll come to you later what could be the difference between all these devices. Then there's another device is called, we generally gonna write, called router. You can even make a notes during the session in order for easy to understand. So these are the common icons that we use during the design stage. So let's say the other one also could be making the same ideas like hub, switch, bridge. Okay, hope we can continue. The next topic called network topologies. Here you can see there are few technologies in terms of network topology. From this, our network designing is starting from Star Topology. But before, we can have a quick review about what is the meaning of bus and ring topology. This all the topology will refer how your network looks like. Like if you going to see any existing network, or you are going to implement a new network, the one of the key elements that you need to understand, how do I design the network? What are the major or minor equipments or the design field that needs to be included in my design? So the network topology will help us to understand these areas. So we can talk about bus topology. The bus topology is being stopped in 1.5 decades before. But the bus topology is mainly referred that all devices are connected to a single cable, which is called coaxial cable. Then there could be a T4 for closing the connection. You might heard about coaxial cable connectivity. So just to give you a brief idea, like you are pulling the cable, which is a coaxial cable, and if you have any junction, you will put the T connection. This is the T connection. Then again, your cable will be start from here. Again, on the next node, next system side, you will be putting the another T connection. And in the T connection, you will be adding your system with the coaxial connections, coaxial cable. You may heard about the BNC connector. It's very old technology. Then the end of the device that you are going to use the terminator to terminate the connections. This is just for the two system examples, or even you could have more system. So the drawbacks of this network, in shortly, if the cable goes down somewhere else, the further on connections being disconnected, so you cannot communicate it to move forward. Also, the speed of the entire cable will be divided into number of system. Let's say if I have a 100 Mbps cable, if I'm connecting 10 systems into that connections, this will be shared into equally, which means my each system gonna take a 10 Mbps speed. Do not need to more think about this because this is not gonna use nowadays. The other one, the next technology called ring topology. Ring topology means this is not the physically look like a ring. This is the concept of the design. So this has been introduced by IBM. So there is a central product. There is a central product or the product called MAU. MAU, multi-station access unit, or MSAU. Multi-station access unit. This is something like a switch, and this device will have a connection where you can connect all your system. It is look like a switch or hub. Then what makes difference in this MSAU? There is a protocol running within the MSAU. So this MSAU protocol will go to the first port to analyze if there is any service that he needs to forward. So in a simple way, I am the MSAU. You guys are connected to me. Okay. So let's say one of the person who connected to the first port wants to talk to the third port. They cannot communicate directly. There is a protocol running within the network. As example, I am the protocol. I used to come to every port to analyze, is there any service need to be recognized? So, Nyananda Parayana protocol, Ella portalum carry arangite, Oro portalum connecti the system at the endingilum communication chayanamo in the chodichi, available service at the Tana at the port like Pua. Let's say Randamatha portni yadri communication milla angle. ആദ്യത്തെ പോർട്ടിൽ നിന്ന് ഇറങ്ങി വന്നു കഴിഞ്ഞാൽ മൂന്നാമത്തെ പോർട്ടിലേക്ക് നേരിട്ട് പോവില്ല. അത് രണ്ടാമത്തെ പോർട്ട് പോയി ചെക്ക് ചെയ്തിട്ട് മൂന്നാമത്തെ പോർട്ടിലേക്ക് വരുള്ളൂ. Okay, so we are not going to use MSAU. We are starting our design from Star Topology. That is the first and foremost topology which is using in the existing or the current industry. So what is the meaning of Star Topology? Like, if I hope you guys are majority into the implementation designing side. Let's say I'm going to tell you I need to connect 10 edge devices into my network, or simply I'm going to say I need a 10 camera, 1 NVR for my organization. So you guys are preparing the BOQ. So that BOQ will contain, let's say, 9 camera. This camera considered as an edge devices, 1 NVR in order to record those cameras. Then 1, let's say, UPS for them to have a backup, and 1, let's say, rack, small rack, maybe wall mounted rack or some other type of rack. Along with that, all the 9 cameras need to communicate it to the NVR and vice versa. So I must need a switch or any relevant network equipment. We have a network equipment, just keep in mind, repeater, hub, bridge, switch. Okay, I'll tell you later what is the difference between them and why we majority focusing into switch. But just for understanding, we can gonna start from the switch itself for a time being. So let's say in my entire building, I must have to, and also I need one screen and 1 workstation. I'm not going to talk about the like a CCTV requirement. I'm just talking about the Star Topology. What does meaning of, what do you mean by the Star Topology? Let's say in my office, I have connected 1 switch. Okay. 1 switch, and this is my rack. The room where my rack is located, we call it as IDF. So I have a switch, I have NVR, and my camera distributed across the building or across the office. And from every camera, let's say I have a camera in different areas, maybe entrance, maybe exit, maybe inside the room or somewhere else. We distributed 9 camera, and from every camera, they are pulling the cable and coming to my IDF. And in the IDF, there must be a patch panel, and there is also a cable manager for arranging the cables, etc. So from the patch panel on the front end, I'm putting my small patch code. Let me know if you have any doubt in between anywhere. So from my patch panel, I'm just, let's say I'm putting the P1, patch panel 1, then I'm referring a number 1, number 2, number 3 like this, maybe 24 ports patch panel or 48 ports patch panel. And my switch first port will be connecting to my first port of the patch panel. And second port of the patch panel. Like that I'm connecting. Also, I'm going to use the NVR connecting to one of the port in the same switch. So my NVR is talking to the field camera over the cable towards to the switch. So the camera, so the NVR talking to the switch, and the switch is talking to the camera. So this is one of the smallest design. So here I involved switch and my edge devices. So this type of network architecture we would refer as star topology. Do you guys have any doubt? So you can replace from the 9 cameras into maximum number of cameras, or even from the camera side, you can use any edge devices. It could be your desktop, laptop, printers, access control system, or a building management system, or it could be anything, access points. And from the number of switch, you can be increased 2 or 3 or 4, depends on the requirement. Even from the NVR, you can increase the NVR. So our consideration here to what is the meaning of the star topology. So that you have a system or the edge devices connected to a switch. In a simple way, you have a one switch, which is port number 1, start, at port number 24, end, 24 port switch. You have an n number of edge devices, which is far away. So this will be connecting to every port, like the second port, third port, fourth port. When you're connecting your edge devices to the respective switch port, there is a proper case studies and the design consideration, the best design architecture when we can discuss later on the stage. So you are connecting your edge devices into the switch. This is called star topology. Hope you understood. So here you can see one device have multiple edge devices connected to this, called the star topology. Now we have extended star topology. The extended star topology is currently using everywhere. So I said the star topology is using everywhere. Now I am saying extended star topology is using everywhere. Do not be confused. When you have small number of requirements connecting to one switch, this we call it as a star topology. Maybe you purchased 24 port switch and you have edge devices which is less than 24 ports. Maybe 10 access points, 5 desktop, 10 telephones, or even attendant mission for few, which is altogether lesser than 24 ports, which can be accommodate in one single switch, that we can refer as a star topology. എന്ന് വെച്ചാല് നിങ്ങളുടെ കയ്യിൽ ഒരു സ്വിച്ച് ഉണ്ട്, സ്വിച്ചിന്റെ അല്ലെങ്കിൽ ഹബ് ഉണ്ട്, അതിന്റെ പോർട്ട് 24 പോർട്സ്. ഒരു 24 പോർട്ടിന്റെ സ്വിച്ച് നിങ്ങളുടെ കയ്യിലുണ്ട്. അത് നിങ്ങൾ ഡിസൈൻ ചെയ്യുമ്പോൾ നിങ്ങളുടെ എഡ്ജ് ഡിവൈസിന്റെ റിക്വയർമെന്റ് 24-ൽ താഴെയാണെങ്കിൽ നിങ്ങൾക്ക് ഒരു സ്വിച്ച് വെച്ച് തന്നെ ഡിസൈൻ ചെയ്യാം. ഓക്കെ, ഓർ 24-ന്റെ മുകളിലാണ് പക്ഷേ 48-ന്റെ താഴെയാണെങ്കിൽ നിങ്ങൾക്ക് ഒരു 48 പോർട്ടിന്റെ സ്വിച്ച് വെച്ച് തന്നെ ഡിസൈൻ ചെയ്യാം. അങ്ങനെ ഡിസൈൻ ചെയ്യുമ്പോൾ അതൊരു സ്റ്റാർ ടോപ്പോളജി ആയി. ഇനി 48 പോർട്ട് സ്വിച്ചിനെക്കാളും വില കുറവാണ് 2 24 പോർട്ട് വാങ്ങിക്കുന്നത് എങ്കിൽ That depends upon the budgetary. പക്ഷേ ഒരു സ്വിച്ചിന് പകരം 2 സ്വിച്ച് വാങ്ങിക്കുമ്പോൾ നിങ്ങൾ അവിടെ അഡീഷണലി കൺസിഡർ ചെയ്യേണ്ടത് സ്റ്റാക്കിംഗ് കേബിൾ, സ്റ്റാക്ക് ചെയ്യണം, എക്സ്ട്രാ കോൺഫിഗറേഷൻ, അങ്ങനെ ചില ഏരിയാസും ഉണ്ട്. അപ്പം ഇനീഷ്യലി നമ്മൾ എന്ത് ചെയ്യുന്നു വെച്ച് കഴിഞ്ഞാൽ പ്രൊക്യൂർ ചെയ്യുമ്പം BOQ റെഫർ ചെയ്യുമ്പം ബഡ്ജറ്റ് ഫ്രീ ബേസ് ചെയ്യുമ്പം ഏതാണോ ബെസ്റ്റ് എന്നുള്ളത് നോക്കും. ഒരു സ്വിച്ചിൽ കണക്ട് ചെയ്യുന്ന അത്രയേ എഡ്ജ് ഡിവൈസ് ഉള്ളൂ എങ്കിൽ സ്റ്റാർ ടോപ്പോളജി. ഒന്നിൽ കൂടുതൽ സ്വിച്ചുകൾ തമ്മിൽ ഇന്റർ കണക്ട് ചെയ്ത് ഡിസൈൻ ചെയ്യണമെങ്കിൽ അതിന് വിളിക്കുന്ന പേരാണ് എക്സ്റ്റെൻഡഡ് സ്റ്റാർ ടോപ്പോളജി. ഇപ്പം നിങ്ങൾ ഈ എക്സാമ്പിൾസിനകത്ത് നോക്കിക്കഴിഞ്ഞാൽ അറിയാൻ പറ്റും. 4-5 സ്വിച്ച് ഉണ്ട്. ഓരോ സ്വിച്ചിലും ഒരുപാട് ഡിവൈസുകൾ കണക്റ്റഡ് ആണ്. ലെറ്റ്സ് 3 ഡിവൈസുകൾ വെച്ച് ഓരോ സ്വിച്ചിലും അങ്ങനെയുള്ള 4 സ്വിച്ച് ഒരു സെൻട്രൽ സ്വിച്ചിലേക്ക് കണക്ട് ചെയ്തിട്ടുണ്ട്. ഇതിന് സ്വിച്ച് എന്ന് പറയാൻ കാരണം നിങ്ങൾ അതിനകത്ത് നോക്കിക്കഴിഞ്ഞാൽ 4 വരയുണ്ട്. അല്ലെങ്കിൽ മുകളിലത്തത് 2 ഒരു വരയും താഴത്തത് 2 ഒരു വരയും. ഇതിനെയാണ് നമ്മൾ സ്വിച്ച് എന്ന് പറയുക. Okay, so this is also one of the example for star topology. Any doubt? So being here, we have discussed about what is LAN, what is WAN. LAN is a single or the local network. WAN is between multiple locations. Then we also discussed about the topology, which is star and extended star topology. Okay, so thank you for connecting with us. Have a good day.